Good evening, class. We are looking at College Algebra Practice Test 4, Module 4, covering Chapters 7 and 8. Here's Chapter 7, Systems of Linear and Nonlinear Equations. Here's Chapter 8, Analytic Geometry. And tonight we're going to cover Chapter 7, Systems of Linear and Nonlinear Equations. So let's look at some of the definitions we've seen. If the system of a linear equation results in two parallel lines, the system is an inconsistent system. The system has no solutions. The graphs are parallel lines. They have the same slope, but different y-intercepts. So here's an example of that. Here's an example of graph. So they have equal slopes, meaning m1 equals m2, but different y-intercepts, meaning b1 and b2 are different. So this is one of the y-intercepts. This is another one. If we were to solve it by any method, for example, substitution or elimination, we end up with contradictions such as 0 equals 7, 2 equals 5, things of that nature, which is a false statement. Indicates the system has no solution, the system is inconsistent. If the system of linear equations results in two intersecting lines, the system is consistent system with independent equations. The system has a single solution. At the point of intersection, the graphs are different. They have different slopes. So, for example, here the point of intersection is the solution. Basically, they have different slopes. M1 is not equal to M2. And finally, if the system of linear equations results in a single line, the system is a consistent system with dependent equations. Normally, we say it's a dependent system. The system has an infinite number of solutions. The graphs are identical. They have the same slope and the same y-intercept. So ultimately, if you solve for y, they become identical. Not only m1 equals to m2, also b1 is equal to b2. If we were to solve it by substitution or elimination, an identity such as 0 equals 0, 5 equals 5, and so on, indicates the system has an infinite number of solutions. The equations are dependent. So let's look at some of the simple examples to see how we solve systems of equations. Again, we are looking at linear equations. So for this one, you notice that this has 5, and so if I multiply this one by 5, they can undo each other. So by the method of elimination, let's multiply the first one by 5. And that gives you minus 5x plus 10y equals minus 5. The second equation, we just repeat it the way it was given. Notice when we add them up, these two cancel each other. These two cancel each other. So the left side becomes 0. But the right side is not 0, happen to be 1, any number. Is this a true statement? No. This is a false statement. That means no solution. That means we should have had parallel lines to begin with. So if we were to solve for y, we would notice that they have equal slopes, different y-intercepts. What about this one? There are a couple of different ways. I can multiply this one, for example, by 3, this one by 7, if I want to eliminate the y. Or I can multiply this one by 5, this one by 2, if I want to eliminate the x variable. It's your choice. So let's multiply this one by 3, this one by 7. So this gives us 6x minus 21y equals 9. This gives us negative 35x plus 21y equals 49. These two cancel each other. These two add up to negative 29x, and these two add up to 58. Divide both sides by negative 29, x becomes negative 2. Now, we are going to use one of the original equations. For example, if we use equation 1 and replace the x with negative 2, we get minus 4 minus 7y equals 3. This changes sign, becomes 7. Division by negative 7 results in negative 1. So x is negative 2, y is negative 1. It is extremely important that you guys check. You must check. How do you check it? We already used equation 1. So if you put that in equation 2 and it works, we are done. So let's use this one. Minus 5 times minus 2 plus 3 times minus 1 equals 7. We are asking this question. As you can see, the answer is yes. It checks. So you have to check your work. Matrices. Let me remind you of matrices. A rectangular array or table of numbers is called a matrix. A matrix with m rows and n columns as dimension of m by n. So we have m rows, 1, 2, 3, and then n columns. A square matrix has the same number of rows as columns, and the dimensions would be n by n. We can add matrices with the same dimensions. They must have identical dimensions, otherwise we can't. And how do we add them up? Just corresponding elements. For example, I have to add these two, and I get 1. Then I have to add these two, and I get 0. Then I add these two, and I get 16. Then I add these two, and I get 6. Each case is a 2 by 2 matrix. Notice they represent every element as A, I, J, A sub I, J. I refers to the location of a row and J column. So this would be A11, this would be A12, this would be A21, A22. The product AB of an M by N matrix A and N by K matrix B is an M by K. In other words, you can multiply matrices if the number of columns N, in this case, for the first one, is identical to the number of rows for this one. So when we look at this one, first I want to write the dimension so it becomes clear. I highly recommend you start with the dimension so you know how it works. So this one has 2 rows and 3 columns. We call it 2 by 3. And this one has 3 rows and 2 columns. We call them 3 by 2. So again, go back here. 1 row, 2 rows, 1, 2, 3 columns. This one, 1, 2, 3 rows, 1, 2 columns. So the way it works, first I would figure out the resulting size dimension. So 2 by 3, 3 by 2. So you get the first one from here and the last one from here. The resulting matrix must be a 2 by 2, everybody. So the result must be a 2 by 2 matrix. Okay. So how do we do the multiplication? We multiply this row by this row and it becomes the first entry. So I'm going to show you up here, minus 3 times minus 6, 4 times 2, 2 times 3. So negative 3 times negative 6 plus 4 times 2 plus 2 times 3. So this is 18, 8, 6. They add up to 32. So this will result in the very first entry here as 32. Now, if I multiply this one by this one, I get the second entry in the first row. So negative 3 times 4. Let me just write that with a different color. So negative 3 times 4 plus 4 times 3. Obviously, they cancel each other. They give us 0. Plus 2 times negative 2. And the answer is negative 4. So I hope you see that we did this too. And now multiply this one by this one, you get this one. Multiply this one by this one, and you get the last two. That's how the multiplication works. Let me erase the mess. Matrix methods to solve systems of linear equations, REF, short for row echelon method. Apply row transformations to get ones along the diagonal. A leading coefficient is 1, and zeros below the augmented matrix. Or REF, it's called reduced row echelon method. Apply row transformation to get ones along the diagonal and zeros both below and above. The augmented matrix, that is what we are going to work on. Every leading one is to the right of the one above it, and any non-zero rows are always above rows with all zeros. So what do we mean by that? Let's look at the same question, 2a, that we just did, but using this method. So we have seen the question, but we want to look at it from a different point of view. Okay, so as far as the augmented matrix is concerned, everybody, you just write the coefficients. So minus 1, 2, minus 1, 5, minus 10, 6. And we just write them again, negative 1, 2, negative 1, 5, negative 10, 6. And the reason we have a line segment here to separate this, which is the coefficient matrix. Okay, this is the coefficient matrix. When we put them next to each other, this becomes a augmented matrix. So if we had only this part, only this one, in other words, let me write it up here. If I just wrote negative 1, 2, 5, negative 10, the name is coefficient. matrix. Okay. Whereas only this one is the solution matrix. And that would be just this one. Okay. Now putting them together, it's an augmented matrix. So the very first thing we want to achieve is to make this guy 1. And there are different ways of doing it. The fastest way would be if we multiply this one by -1. So we can't just multiply this one by -1. We can multiply all entries of the row, because what we are doing it to the equation. We can multiply both sides by the same number. So the notation is minus R1 changes the R1. So multiply everything by -1. This becomes 1, -2, this becomes 1. But we are not changing the second part. Now what we want to do is to get this 1. So the first thing is to make sure this is 1. We achieve that. Now, this happened to have only 2 rows, but even if it has 10 rows, now the next steps would be to make every entry under 1 0. And again, this is using the row transformation. Whatever we could do to an equation, we can do to matrices. So remember, for example, you can add multiples of one equation to the other one. So how do I make this 0? If I multiply this one by 5 and subtract it from this, so minus 5 R1 plus R2 becomes the new R2. So if I multiply this one by -5, I get -5 and 5 is 0. I multiply this one by -5, I get +10 and -10 is 0. If I multiply this one by -5, I get -5 and 6 becomes 1. Okay. So I'm going to repeat that so everybody can see. If I multiply this one by -5, add it to 5, I get 0. If I multiply this one by -5, I get +10 and -10, I get 0. If I multiply this one by 5 and add it to this, I get 1. This is the meaning of that. Now, what happens is that the final row, so what this means, if I were to rewrite this, going back from the augmented matrix to the equality, it would mean the following. This would mean 1 times x. Instead of x, I'm going to write 1 times x minus 2 times y equals 1. And this would mean 0 times x plus 0 times y equals 1. And here's the problem. If in essence, this means this side is 0, this side is 1, this is a false statement, and therefore there is no solutions. So the final row indicates that the system is inconsistent and has a solution set. This is called phi, or an empty set. So how do we know that? If every entry is 0 except the last one? Every entry is 0. Every entry is 0 except the last one. Doesn't matter what it is, 1 or anything else. Last one, the last entry. Of course, when it gets complicated, you can use a calculator on that, but I want to show you the methodology for the calculator. First and foremost, for example, if you're using a TI calculator, you're going to go to matrix editor, found by pressing second and X inverse. Okay. Use the arrow key to the right to edit the dimensions, and then put all the entries. So how to solve row echelon form? Matrix editor found by pressing second x to the power of -1, math, and REF, the very first one, and matrix A. So take a look at what we are going to do. So matrix A is 2 by 3, okay, and we put -1, 2, -1. We put those 3. And then the bottom is 5, -10, 6. Okay, so that's putting the matrix in. And now if we say REF A and enter, results in this. Now, what you get may not be identical to what they have because the process may not be identical. This is our process. They may have a different process. But what happens is that the result will be identical. The result must be identical. And this indicates the same thing that we have done. Okay. So if I were to show you here with a TI calculator following this, second, inverse, and edit, and we are going to make this a 2 by 3, and the first entry is -1, the second one is 2, the third one is -1, and now we go to the second row. The first entry is 5, the next one is -10, enter, and the last one is 6, enter. Now we have matrix A. We are going to go back to matrices. We got to go to math, the right, and now we are looking for REF. And I just found REF. I'm going to say enter. A matrix. So let's see. No, that's not what I want. Second. And it results in 1, -2, 1.2001, and that is the same result that we had here. Okay. So that's how you use a calculator. All right. Let's move on, class. Let's do 2B. And again, I'm going to show you both ways, by hand and using a calculator. So we want to come up with the augmented matrix, which means we are going to go with just the entries that are the coefficients 2, -7, and then 3, -5, 3, 7. And again, this line indicates that we are separating the coefficient matrix from the solution matrix. Putting them together becomes an augmented matrix. The first thing is to make this 2. I can divide everything by 2, and that's fine, except when we create fractions, it makes it a little bit more difficult to move on. So to avoid that, I can say 3 times this. If I multiply this by 3, this becomes 6, and if I add this one to it, it gives me the one I'm looking for. So I'm going to write 3R1 plus R2 gives us R1. So if I multiply this one by 3, I get 6 and minus 5, this becomes 1. Okay. If I multiply this one by 3, I get negative 21. With 3 becomes minus 18. If I multiply this one by 3, I get 9 and 7, 16. So notice, again, just for the sake of argument, the first entry, 3 times. So multiply this by 3 and add the second row to it. So multiply this by 3 and add the second row. That's what it means. So the first entry is 1. That's what I've been looking for. I got, so again, the idea is to change this to 1. We did. Now, everything underneath must become 0. So we want to make this into a 0 using row transformation, meaning whatever we can do with the equation. So what you do, you just write the first one, and then you say, okay, what do I do to get a 0? You put a 0 here, and then you figure it out. You can even put a 0 and say, okay, how do I achieve that? And there are different ways. The fastest way, if you multiply this one by 5 and add to this. So you're going to write 5R1 plus R2. It's a new R2 now that goes into R2. So 5 times this and this one gives us 0. Now, 5 times negative 18 becomes negative 90, and 3 becomes negative 87. Negative 87. If you multiply this by 5, you get 80 plus 7, 87. So I hope you see that again. Multiply this row by 5 and add it to this row. That's the meaning of this. So far, so good. The next one is to make this entry into a 1. And all you have to do, this row, which is the equation in essence, you can divide by negative 87. When you divide this, so the first one doesn't change, remains unchanged. This becomes remains at 0. This becomes 1, and this becomes negative 1. So what is the equation corresponding to that? 1 times x, or x, minus 18y equals 16. 0 times x plus 1y equals negative 1. And so what this means really, the second variable is negative 1. That's the meaning of it. Okay. So it does have the answer. Now, all you have to do, put the negative 1 into this one by writing, okay, x minus 18 times y, which is negative 1, equals 16. And that means x plus 18 is 16, and x becomes negative 2. Okay, x becomes negative 2. And so we have the pair in essence, negative 2, comma negative. What I want to show you is, again, the matrix, I showed you how to enter and how to do the ref. And so this is the augmented matrix that has been put in there. Then we put the ref, okay, row echelon form, ref, row echelon form. And you put the matrix A, you don't forget the parentheses, enter it. And here's what you have. And please understand, this may be different than ours. By that, I mean different than this one, okay? But nevertheless, this indicates y is negative 1. Do you follow what I'm saying? And you can put it into this now, x minus 0.6, y equals negative 1.4, solve it. Or you can go to the original one. Either way makes no difference. Now, instead of ref, if I put REF, okay, which means row, reduced row echelon form, or REF, I get this one. This is an identity matrix, everybody. This one is an identity matrix. And this is the solution. X is -2, Y is -1. So our REF will finish the job for you. REF gives you one of the solutions in this case, okay? So that's the difference. So those are using matrices. If we want to use a different method, now it's called Cramer's rule. Again, I want you to be exposed to all types of methodology to solve the system. What do we do? So let me go over a couple of steps you need to know. Number one, determinant. The determinant of a 2x2 matrix, A equals A, B, C, D, is denoted by their cross product, okay? So AD A times D, B times C, their difference, AD minus BC. So according to Cramer's rule, if we have this system of a 2x2, we can use X by finding the determinant of known as D sub X, D sub Y, and then D as follows. Now, first I want to explain the D. The D is the determinant of the coefficient matrix. Notice A, B, C, D. Now, D sub X, we replace the coefficients of that with the solution ST. D sub Y, we keep that and we replace the second column. Okay. So the determinant of A, B, C, D is AD minus BC, which is not 0. Note we replace the first column of D by the solution matrix for D sub X. So D sub X, here's the solution matrix, ST. And we replace the second column of D by the solution matrix for D sub Y. If I want D sub Y, the second column is changed. If D happened to be 0, if this becomes 0, and at least one of the determinants, D sub X or D sub Y or D sub Z, if I'm writing D sub Z, if we have 3 variables, one of those determinants is different from 0, then the system is inconsistent and the solution set is an empty set. So I want to repeat that. If this D becomes 0 and one of those is not, then it's an inconsistent system. If D is 0 and all of those determinants are equal to 0, then the system is consistent and dependent, so that there are infinitely many solutions. So let's see what we are going to do to solve this. So first I'm going to look at the coefficient matrix and the coefficient determinant by writing 2, minus 5, minus 7, and 3. Okay, and do the cross product. So 2 times 3 minus, 2 times 3 minus 5 times -7. Minus 5 times -7. So minus 35 becomes -29. Now, for D sub X, I want to go for D sub X because I want to write this. So I write the same thing, and because of D sub X, I'm going to change this to a -5 to 3 and 7. but the second column remains intact. This is the one that has been changed. I hope everybody's clear on that. So what do we get now? We multiply these two, 3 times 3 minus, multiply these two. So what do we have? 3 times 3, let me just work it out for you. 9, and then minus times minus is plus. 49, we get 58. Now, we go back to this. Since we want d sub y, we keep the first column, but this one, we change it with the solution matrix 3, 7. So this was changed. Now this one is changed, okay? So 2 times 7 minus negative 5 times 3. 14 plus 15 is 29. So x is d sub x over d. 58 over negative 29, and it's negative 2. Y is d sub y over d. 29 over negative 29, which makes it negative 1, which is exactly what we got before. So we solve this by the elimination method, by the method of row echelon form and reduced row echelon form using augmented matrix. And now we use the Cramer's rule. What happens when we have more than 2 rows and 2 columns? Again, in order to calculate the determinant, you need a square matrix. This is a 3 by 3. So the methodology is, if you have this one, first of all, you can expand it with respect to any rows or columns. Okay. So if we decide to expand it with respect to the first row. So when you do that, for example, A11, you cross this out and times what is left. When you get, so A11 times this determinant, then you go with the negative. You alternate the sign, minus this one, and you drop this one. You have these two. And then plus this one times you drop this one, and you write this matrix. Again, this alternates, everybody. Please understand that this will alternate. Okay. In other words, if we had one more, then this is positive, negative, positive, negative. There's also a formula for that. A to the power of, if I want to go over the formula for you, there is, if you are if you multiply Aij, the sign that you use for this one is -1 to the power of I plus j. And because this 1 and 1, it adds up to 2, this is positive. 1 and 2 adds up to 3, this becomes negative, and so forth. This is how you can figure it out, because one may start from here. Okay, and right, this one starts with negative, just for the sake of one. All right. So the 2 by 2 determinant are called minors of the 3 by 3 matrix. You know, determinant, this one, and this one are called the minors. As far as the terminology is concerned. We choose to expand across row 1. You can choose any row or column. So we're going to use this one. So in essence, you can, I'm going to put a cross here. That means if I want to go with this one, I'm going to put a cross here. So 5 times the matrix this one. Now minus -8. Now the matrix would be 3, 4, minus 5, 1. And then plus 6. If I cross this out, this would be the matrix. Okay. So again, I repeat 5. And then the matrix would be those two. -8. Put a line here and would be this 2 and this 2. And then 6, put a line here, would be this. As far as the signage, as I said, this becomes negative, this negative, and so forth. Okay. So you want to be very careful with that as to why this is the case. And as long as you pay attention to that, you won't make a mistake. It's extremely important, everybody. And so with that being the case, this one would be 0 times 1 minus -2 times 4. This would be 3 times 1 minus -5 times 4. This would be 3 times -2 minus -5 times 0. And don't forget those numbers in front of them. This is 5, this is plus 8, this is plus 6, this is plus 8. So we have, for this one, 5 times 0 minus -8. For this one, okay, minus -8, meaning plus 8. Okay, 3 minus the product of these two, which is -2, plus 6. The product of these two, which is -6, minus the product of these two, which is 0. And we get 188. That's basic math you just add. So if we were to do this by hand, this is how we would do that. Okay, and that's fine. Now, what if we want to do it using technology? That means we are going to go with the 3 by 3. I'm using a matrix P here. And you put the entries, okay, 5 minus 8, 6, 3, 0, 4, minus 5, minus 2, 1. And all you have to do, go to the math part of the matrix and put determinant. So if you put determinant of B, it just gives you the answer. Also, there is another way if you want to do it by hand, and that would be, here's the second method. You put 2 of those next to each other. You put 2 of those next to each other. So you write this one and again repeat it. And then pay attention to this. When you do that, start from the very beginning and go diagonally down. Multiply, add them up. Then when you're done, the next one, you go diagonally this way, add them up, and then subtract it from those. In other words, this minus the sum of those. So how do we do that? I'm going to use different colors. So I'm going to go diagonally. So 5 times 0 times 1 plus -8 times 4 times -5 plus 6 times 3 times -2. Now I'm going to subtract from this the sum of these three. So minus, and I'm going to put in a brackets, minus 5 times 0 times 6 plus -2 times 4 times 5 plus 1 times 3 times -8. Please understand, I'm adding the red ones, I'm adding the blue ones, and I'm subtracting all the red ones from the blue ones, and that gives you the same answer. Again, some people find this a tad easier, but it's absolutely your choice. I'm going to solve this, and again, I want to show you by hand. Of course, the more complicated the systems, the better the possibility of using technology. But you should be able to do it by hand if need be. So how do we do that? Well, Remember what you have here. You have three equations. You want to go to 2 and then to 1. That's what we did with the 2 by 2. We went to one equation by elimination of one of those equations. So you always want to go with the easiest way possible. First of all, let's give them numbers. So we're going to call them equation 1, equation 2, equation 3. Those are the original equations. Okay. Now, you decide which variable to get rid of. Because this is negative 4y and 4y, it's easy to see that if we don't do anything, we just combine 1 and 2, the y goes away. So first make a decision which variable. Of course, you don't have to get rid of the y. You can get rid of the z, or you can get rid of the x. But I just noticed this is minus 4y, this is plus 4y. That's the fastest way. So I'm going to choose to get rid of the y. So I'm going to combine equations 1 and 2. When I combine these two, let me just combine them and then I erase. I'm going to combine these two. When I combine these two cancel each other. And I get 5x plus 3z equals minus 15 and 16. They add up to positive 1. Okay. Again, I think it's pretty straightforward. All right. So because I did that, now which equation hasn't been used yet? Number 3. You must use number 3. Do you use it with the first one or second one? Makes no difference as long as number 3 is used. Again, but we want to get rid of the same variable, namely the y variable. Okay, we want to get rid of the same variable, everybody, and that's extremely important to pay attention to. So with that being the case, if I want to get rid of the y here, so let me just erase. So if I want to use this one and this one, okay, this is minus 4, this is positive 3, so I can multiply this one by 4, multiply this one by 3. So if I multiply this one by 3, I get 9x minus 12y plus 6c equals minus 45. I multiply this one by 4, I get 8x plus 12y plus 20z equals 80. And now when I combine them, these two cancel out. And I get 17x plus 26z equals 35. And I'm going to call it equation number 5. Equation 1, 2, 3. Combining these two, we got equation number 4. And combining these two, we got equation number 5. And now we are dealing with a 2 by 2 system. And therefore, what I'm going to do, I'm going to put these two next to each other. Equation 4 and equation 5, I'm going to put them next to each other and deal with those. Again, you have to decide which variable you want to get rid of. If you want to get rid of the x, you can multiply this one, let's say by 17, this one by negative 5. If you want to get rid of the z, you can multiply this one by 26, this one by negative 3. So let's go and multiply the top one by 17. And we get 85x plus 51z equals 17. So we have to multiply this one by negative 5. Gives us 17x times negative 5 or minus 85x. 26z times minus 5 is negative 130z. And negative 5 times 35 is negative 175. And when we combine these two cancel each other. We can add these two to negative 79z and these two to negative 158. If we divide by negative 79, z becomes 2. We got one of the variables. Okay, we have one of the variables. So what we are going to do now, we go to one of these two. We don't go to the original ones yet, because we have three variables here, we can't solve it. But we go back here. If I put the z into the equation 4 or 5 makes no difference. I can find the x. So let's go with equation 4. 5 times x plus 3 times 2 equals 1. Of course, this is 6. Moves to the other side, becomes negative. And it becomes negative 5 divided by 5, and x becomes negative 1. So we got two of the variables. We need to find the third one, and now we are going to go with one of the original equations. It doesn't matter which one, for example, the first one. And we plug in 3 times negative 1 minus 4 times y, which is missing, plus 2 times z, which is 2, is negative 15. So this becomes negative 3. Let's just write it down. And negative 3 and 4 becomes negative 1. Let's see if I can use here. So we have negative 1 minus 4y on the left side. So I'm going to move the negative 1. My apologies, positive 1, because it's negative 3 plus 1. So we have 1 minus 4y. So when I move it to the other side, it becomes negative 1, and therefore minus 4y is negative 16, and y becomes positive 4. And that's the answer. And it's important to write it in this manner so it makes it easy to see x, y, z. And we're done, okay? But let us write this using matrices. So let's write this augmented matrix, which is 3, 2, 2, minus 4, 4, 3, 2, 1, 5, minus 15, 16, 20. I went column wise. You can go row wise, 3 minus 4, 2 minus 15, so on and so on. So it's a 3 by 4 you are going to write, okay? Now, because there wasn't enough room, I wrote it 2 times. So it didn't show the fourth column. It showed the first, second, third. So I went with an arrow to the right. And I'm showing you this is the second, this is the third, and now this is the fourth row. I just wanted you to see that's all. And so now I can go with REF. So this is the matrix I was talking about. If I go with REF, notice 1, the rest of them 0. 1 below is 0. Okay, and again, I didn't have room. 1, and again, to the left is 0. Right here, this represents the last variable z. So 1 z equals 2, which means z equals 2. So this says z equals 2. Okay. You can change the answer to fractions, okay? And that gives you the precise answer. So answer to fractions. However, if you do the, instead of REF, which is row echelon form, if I do REF, reduce row echelon form, then in one shot I have the answer. Look at my answers here. The answers here, okay? Here's the answers. Here's what we got by hand, and everybody's happy. All right, going to solve this system. And again, you can use either way, technology or by hand. You probably notice if I multiply this one by 8, because this one has two variables, I can get rid of the y. Notice what happens if I multiply this one by 8. And I just deal with the third one. So this becomes 16y plus 24z minus 112. So when I add them up, this cancels out, this cancels out, I get 0 here, but over here I get a negative 224, which is a false statement. No solutions again. These two cancel each other, okay? So it was pretty easy to do it by hand. This one, if I multiply this one by 3, I can get rid of the x. So let's multiply by 3, and this becomes minus 3x minus 9y, and this becomes negative 6. As you can see, everything cancels out. So you get 0 equals 0, which is a true statement. And that means we have a dependent system with infinitely many solutions. Dependent system with infinitely many solutions. Now, how do you represent that? In many texts, they write one of the variables, normally x, and the other one as a function of x. If you go to any of them, for example, for this one, and you solve for y, and I'm going to leave it for you to do that. If you solve for y, you get this one, everybody. Okay, and this is the way you represent it. The advantage of that is, if I choose x to be 1, I replace this one with 1. 5, replace it with 1. There with 5. There are infinitely many solutions, everybody, okay? It's a dependent system. Let's do it with the matrices. So here's the matrix A. If I go with row echelon form, the bottom row consists of nothing but zeros. If all of them are zeros, you have a dependent system with infinitely many solutions. I'm going to solve this system, and I'm going to basically choose to go with the same methodology. Okay. So how does that work? If I just add them up, these two go away. So what do we get? 4x squared is 28. X squared is 7, and x is plus minus square root of 7. Now use one of the equations. Obviously, equation 2 is easier, and plug it in. Whether you put square root of 7 or minus square root of 7 makes no difference. When you square it, it becomes 7. And so y squared is 9, and y is plus minus 3. Please understand these two mean 4 solutions as follows. 4 solutions as follows. Minus square root of 7 with minus 3, minus square root of 7 with plus 3, now plus square root of 7 with minus 3, plus square root of 7 with positive 3. So you have 4 solutions, and you should check, and the way you check it, because we used equation 2, okay, because we used equation 2, just check with equation 1. And just for the sake of argument, if I use this one, let's just quickly, if I use this one, I get 3 times minus square root of 7 squared minus negative 3 squared. Is that equal to 12? So this is 7, this is 21, minus this is 9 is equal to 12. It checks, okay? And you can do the rest. Graph the system of inequalities, and to do so, first you graph systems of equalities. And the way it works, you set this to equal, you set this to equal. Those are easy lines to graph. This one, we need 2 pairs. If x is 0, y is negative 2. If y is 0, x is 1. This one, x is 0, y is 3, y is 0, x is 2. Okay, I'm assuming nobody has any problem with intercepts. And so you graph the two lines. This is 2x minus y equals 2. This is 3x plus 2y equals 6. And please understand you have 1, 2, 3, 4 regions. 4 regions. And one of those 4 is the solution. You can pick any test point, for example, that as long as it doesn't belong to the lines. And by the way, understand that this has no equality, the red one, so it's dashed line. This has equality, is a solid line. So that's why we change this to a dashed line, okay? Now pick a test point such as 0, 0, and we put it into the original inequalities, okay? So if I put 0, 0, in here makes it 0 less than 2, which is a true statement, but over here 0 larger than or equal to 6 makes it a false statement. So this is a true statement. And so for the red one, which we changed it to a green one, it becomes, in essence, this side, okay? And for the blue one, because 0 larger than or equal to 6 is a false statement, it's the opposite side. So this is the blue one. This doesn't work, so this side doesn't work. The opposite side. And as you can see, there are 1, 2, 3, 4 regions. This is the region that the red and blue come together, and that's your solution, okay? And again, don't forget that this is dashed lines, okay? Dashed line, solid line, and y. We want to graph this inequality, and again, we're going to go and graph the equality of y equals x squared plus 1. You know y equals x squared is a parabola that has been shifted up by 1, so this is the graph. And so what happens is that it's either inside the graph or outside. So you pick some point as long as it doesn't belong to the graph, okay? And so, and by the way, the graph itself is not part of the solution because it doesn't have a equality. So pick a point, for example, 0, 2, and check it out. If it works, then we shade the inside. If it doesn't, we do the outside. So replace the x with 0, okay? This becomes 1 and 2. 2 is larger than 1. It's a true statement. And that means this works. So everything inside works. And this is how you do it. By the way, if you have any doubts, pick this one, for example, which is 2, 0, and you see that it won't work, okay? In other words, any point outside. Now we're going to look at the applications. A chemistry lab assistant wants to prepare 10 liters of 48% acid solution. In stock, he has 80% and 40% acid solution. How many liters of each in stock solution should he mix to prepare a 10-liter mixture? This is a class of problem known as a mixture problem. Mixture problem. And you always have to fill up some sort of a table to justify your answer and show your work step by step. And so first thing first, we come up with this table. So the solution we have are 80% solution, 40% solution, and what we are going to mix. And you can write this or not, because this becomes 0.8, this becomes 0.4, and the mixture, of course, 0.48, okay, 0.8, 0.4. You could just, instead of that, right in front of it, you could have written 0.8, 0.4, either in the form of a percentage or decimal makes no difference. Now, what is it that we need? We need 10 liters of 48%. So we need 10 here. And that would be the volume. Okay. Now, how much of each, if we're going to go with the system, I don't know. I'm going to go with some variables. X represents the 80% solution volume and Y represents the 40% solution. So if something is 80% solution, then the product of these two gives you the pure or the actual amount of acid in this case. Okay, so this would be 0.8x. This would be the pure amount 0.4y, and this would be 0.48 times 10 or 4.8. And they must add up. The pure amount does not change. So these two must add up to this. And I hope you realize that the table really gives you the solution, and these two must add up to this. So we have the system of equations. X plus y must add up to 10, and the pure amount must add up to 4.8. On purpose, I put 0.48 times 10. We know it's 4.8. And we can use by substitution, for example, y is 10 minus x here, and replace it here. So 0.8x plus 0.4, and replace the y. When we do that, this doesn't change. This becomes 4 minus 0.4x. As you can see, this one and this one becomes 0.4x. This one is subtracted from 4.8, becomes 0.8. And if you divide by 0.4, you get your answer. X is 2. What does it mean? We have 2 with the proper units. 2 what? Liters of 80% solution. The rest of it, that means 8 liters of 40% solutions. Remember, applications, answer them properly with units. Properly with units, always. Okay, it's extremely important. We are going to move on, class. All right. This is another example of a mixture problem. How many liters of a solution that contains 15% chemical must be mixed with 6 liters of solution containing 10% chemicals to make 10 liters of solution containing 12% chemicals? Again, we need the table. Okay, and the strength, okay, solution strength, volume, pure amount, or actual amount. This is 0.15, this is 0.1, and the mixture is supposed to be 12% or 0.12. So, by the way, we have 6 liters of 10%. Okay, so let's go one by one with that. How many liters of a solution contains 15% here, 10%, okay, and then 10 liters of solutions here, okay. This is 10% or 0.1. This is 12%. And how much of this volume we don't know. It's supposed to be x plus 6. Here. So the pure amount for this one would be the product of these 2.15x. And this one would be 0.1 times 6. And this one would be 0.12 times x plus 6. So they add up. 0.15 times x plus 0.1 times 6 is equal to 0.12 times x plus 6. To make a solution containing 12% chemicals. We don't need this number. This defeats the purpose. All right, so this is 0.15x, this is 0.6, and this is 0.12x, and the product of these two, 6 times 12 is 72. You have two decimals, 0.72. Now we are going to move things around. This one minus 0.12x, and this one minus 0.6. So the left side becomes 0.03x, and the right side becomes 0.12. We divide both sides by 0.03. And this is the same as 12 over 3, which makes it 4. So we need 4 liters of 15% solution. Again, just to recap, how many liters of a solution containing 50% solution must be mixed with 6 liters of solution containing 10% chemical to make a solution containing 12% chemical? This number shouldn't be given in the first place. A plane can travel 800 miles per hour with the wind and 720 miles per hour against the wind. Find the speed of the wind and the speed of the plane in still air, set up a system of equations, and so on. So first we're going to define, and I like to use the initials to define my variables. Plane is doing p miles per hour, wind is doing w miles per hour. So that is one way to do that. It's I think it makes it easier if we go this route, everybody. Okay. And so when we go with the current or the wind in the same direction, the speed of the current or wind will help us, will be added to our speed. And if we are going against it, they will work against us. Therefore, for the with, P plus W. For the against, P minus W. So for the with, P plus W is 800, and against is 720. So that's what we should figure out, everybody. Okay, I hope everybody is comfortable with that. It should make a perfect sense. And so now this is a very simple case as far as the system of equation goes. Okay, we can easily see that these two cancel each other. When we add them up, all you have to do, add them up. These two cancel each other. So 2p is 1520. Divide by 2, and p becomes 760. If the plane is doing 760, the wind must be doing 40 miles per hour. Again, it checks with both equations. Nice and easy, not a big deal. Admission tickets to the Braden River Little League All-Star game cost $4 for adults and $1.50 for children. A total of 225 tickets were sold, and a total of $500 was collected from ticket sales. How many adult tickets and how many children's tickets were sold? Set up a system of equation and solve. Obviously, this is also, in essence, a mixture problem. It is extremely important to be able to set up a table as follows. Adults, children, total, tickets cost, number, total of total amount. So we have to do that in a properly manner. So $4. So you have to read it one more time, and as you read it, you come across $4 that is for adults. You put it here. $1.50 for children. You put it here. We don't know how many of each, so I'm going to go, instead of X and Y for adults, I'm going to go for A. For children, I'm going to go for C. And the total is 225, by the way. The total number of tickets is 225. And the total amount that we collected is 500. And now, so I'm going to go with A and C here. And so how much do we collect from the adults? 4 times A. And from the children, $1.50 times C. And so this gives us one equation, A plus C is 225, and this gives us the second equation, 4A plus 1.5 C is 500. And you can use any method to solve it, substitution, elimination, you name it. If I multiply this one by negative 4, I can get rid of the A, so it becomes minus 4A, minus 4C, minus 900. So, and I'm going to just write equation 2 the way it is, and I'm going to add them up. As I add them up, these two cancel each other. I get negative 2.5 C equals negative 400, and I can divide both sides by negative 2.5, where it becomes 4,000 divided by 25. As you know, 2 zeros can go away because 100 is divisible by 25, becomes 4. 4 times 40 is 160. So you can quickly do it in your head. If C is 160, so C is 160, you subtract it from 225 becomes the number of adults, which is 65. And you really have to check, class. And checking means we just use this one to come up with the answer, okay? You want to check this one to make sure it's correct. One leg of a right triangle is 4 centimeters less than the other leg. The area of a triangle is 70 square centimeters. Determine the length of each leg. Again, set up a system of equations, and so on. So here's the triangle, which is a right triangle. So that means it's a right triangle. One of them is X, one of them is Y. The way I drew it, Y is larger than X. So it says one of the legs, these are the legs, and this is the hypotenuse. The larger side is opposite the 90 degrees angle, called the hypotenuse. It's 4 centimeters less than the other. So X is Y minus 4. And then you know the area is 1/2 base times the height. 1/2 base times the height. When you have a right triangle, the legs are, one of them is the base, one of them is the height. So half of X times Y must be that number. So again, X is Y minus 4, half of X, Y equals 70. And as long as we have those two equations, we should have no problem. Number one, we don't like the fractions when we solve systems. It's easier to get rid of them. So let's get rid of 1/2. If I multiply both sides by 2, this becomes XY, this becomes 140. And now I'm going to replace the X with Y minus 4 here. And so this gives me Y squared minus 4Y equals 140. And I'm going to move the 140. So I'm going to move this, becomes negative 140. And so I want two numbers. The product is negative 140. The sum is negative 4. Those would be negative 14 and 10. And this results in Y equals 14. This results in negative 10. As you know, sides, dimensions can't be negative. So that one is out. If Y is 14, X must be the same thing minus 4, makes it 10. So Y is 14 centimeters, X is 10 centimeters. And you notice if you multiply those and divide by 2, you do get 70. In other words, you can easily and quickly check. Here's the last question. The sum of the three numbers is 105. The third is 11 less than 10 times the second. Twice the first is 7 more than 3 times the second. Find the numbers. First and foremost, we're going to call them A, B, C, X, Y, Z. You have to write something and define your variables. So I'm going to stick with X, Y, Z, everybody. The first number is X. The second one is Y. The third one is Z. And the sum is 105. So they add up to 1 X plus Y plus Z is 105. So that's the first thing we should notice. Now let's write the rest of it. So that's the first equation, everybody. And I put it in blue. Let's look at the second sentence, which gives us the second equation. The third, that means Z is equal to, so Z is equal to 11 less than 10 times the second. So 10Y minus 11. So look at the second sentence in purple. The third, which is Z, is 11 less than 10 times the second. Finally, the third one, twice the first, that means 2 times X, is 7 more than, that means 7 plus 3 times the second, that means 3Y. And as long as we have those three, and I'm going to call them equations 1, 2, 3, we can solve it by any method we want. Okay. And by now you have enough practice. You may combine substitution and elimination or matrices and coming up with the answer. Of course, if you want to use matrices, the variables go to the same side and they must be written in a manner that they are consistent, meaning X, Y, Z. So this would be 0x minus 10y plus z. This would be 2x minus 3y plus 0z. In essence, when you want to write, you better use the augmented matrix or the Cramer's rule, any method that you want to use. All right. So if we look at equation 1, we notice we have a z here and y. We have x and y here, and this has all of it. Okay. So we have x plus y plus z. So if I put the z as 10y minus 11 here, I can get rid of the z here. Okay. So x plus y, and I'm going to put 10y minus 11. Okay. So this way, I'm getting rid of the z. So x plus 11y equals 116. And I'm going to call this equation number 4. Some numbers, so we won't be confused. Now, equation number 4 has x and y variables. Equation number 3 hasn't been used yet, and that has x and y also. So let's put equation 4 and equation 3 next to each other. And we solve them. In order to solve them, okay, if I multiply this one by 2, I get 2x plus 22y equals 232. And since 2x is 7 plus 3y, I can do the substitution. So what I'm doing on purpose, I'm using a different method, combining elimination and substitution, because when you have a 3 by 3, you can use anything you want and invent something if you want to combine things. So I can replace the x with 7 plus 3y, okay. Replace the 2x. I can replace the 2x with this. When I do that, these two combine into 25y. 7 gets subtracted from 232 gives me 225. Let me just, so you see these two are the same, okay, everybody? These two are the same, 2x and 7 plus 3y. And now I'm going to divide by 25, and I get y equals 9. So if y equals 9, if y is equal 9, we're going to go to the original set that we have here. If y equals 9, I can put it into this to get x, and I can put it into this to get z. So equation 2, 10y minus 11. So let's replace the y with 9. Okay, so 10 times 9 makes it 90 minus 11 makes it 79. So z is 79. Now you can use any equation, 2x, and solve it, or you can go with this one, x plus y plus z is 105. That may be easier actually. So you have the y, which is 9, you have the z, which is 79. Okay, x becomes 79. Maybe I write that for you so you see that. Let's see, what color do I want to use? So I'm going to put x plus y plus z. So this is 88. We're going to subtract it, and we get 17. So these are the answers. And as always, we really must check. I'm going to leave it for you to check, everybody.